All right, this is the second half of Module 1. This is Module 1.2, and we're going to continue with the back half of our first module. Study.com, you can look at Chapters 1 and Chapter 6 in the Java Programming Study Guide, where it talks about data types as well as classes, methods, and objects we'll talk about. And then also for this module, in the FTCE Computer Science Study Guide, we'll look at Chapter 7 and 8, which is where our Java programming basics come in. And in CS Awesome, we're going to look at Unit 2, 2.1 through 2.15, covers all the topics that we're going to be discussing in the second half of Module 1 here. So we're going to start with what are objects and classes. So Java is an object-oriented programming language, and we're going to deal with this idea of creating objects out of classes and manipulating those objects when we talk about writing some of our programs. So getting this terminology is important. So we're going to start with a class, and a class is a blueprint for creating objects. Think of it as a blueprint to make a house. You can make different house objects with it. All of these, when you use a blueprint to create an object, they have the same behavior and defined attributes, but they are specific entities made from a class, and you can manipulate these objects in your program. Maybe it's a character in a video game, and you use a class to make multiple characters. Objects are what we call instances of our classes, and we use variables to name these instances as well. We say we instantiate a class. And then each object has, as we mentioned, behaviors and attributes that are defined by the class that was used to create it. So here's an example. Let's use the idea of a class called house. And so it is a blueprint. So here's a blueprint of a house, and we're familiar with the idea of a blueprint for a house. Now, how many house objects can we make using this one class or this one blueprint? Well, we can build lots of different house objects, right? All using the same blueprint. Now, they're not the same house. They look alike. They were made using the same blueprint. However, they are all different colors. Maybe they have all different locations. So when we talk about this house blueprint, we know it has attributes, right? Each house has its own color and location. And maybe we can paint the house, we can change the color, or we can do other things with the house, but we use the same blueprint, the same class, and we have individual distinct objects. So here's some examples of some house objects. We have Rob's house and Sage's house and Jill's house, and all three objects were created using the same blueprint. And I use these visualizations to kind of really just drive home the ideas of what classes and objects are. Right? Each house has its own color and location, and we say that these house objects are instances of classes. They are the objects that we made from this class or from this blueprint. Now, we know that they have attributes such as house color. So we can, maybe there's something in the blueprint in the class that allows us to change the color of a house. So what happens if we change Rob's house to yellow? Would the other houses be affected? Well, no. Even though I use the same blueprint, I can change Rob's house to yellow, but what happens is the other houses still stay the same. And that's what happens when you make an object. Even though you use the same class, the other objects are not affected because each house maintains its own color. Again, objects are instances of the classes, but they have their own attributes, even though we use the same set of blueprints. What about this? What if I have another person that moves in with Jill? We have Jack and Jill in the same house. So now we have two variables that refer to the same house object. We can call this house Jack's house. We can also call it Jill's house. Well, now that we have two variables that refer to the same object, we can say if I change Jill's house, what happens? Jill's house becomes orange. Well, Jack's house is now orange as well because these are two names for the exact same object. But again, no other house objects are affected. So how would we see this in Java? Well, in Java, we might have a house object or house class, and I create a variable called Tim's house. And I would say equals new house is how I would construct or instantiate this class to make an object. And now I've got Tim's house as a variable that refers to a location in memory where this house and the object and all the attributes are located. So the reference variable itself stores the address or the location of where that house is in memory. All right, let's talk about an actual class that exists in Java, the rectangle class. A rectangle is something that has an x and y coordinate. It has a width and a height as well. And we can declare rectangle objects. Here I've declared a rectangle variable called pasta box that is type rectangle, but I didn't make the object yet. I just made the variable. But then on the next line, I created a rectangle called cereal box. And I declared it and I instantiated or constructed that object by saying new rectangle, and then I said 5, 10, 15, 20, or 5, 10, 20, 30. These are my parameters, kind of like we saw when I called the system.out.println. And these parameters are going to be the x, y, width, and height for my rectangle object. And then later on, I can say pasta box equals cereal box. I can assign pasta box to my cereal box. This is kind of like that Jack and Jill situation, 2 names for the same variable. I'll show you what happens. By the way, in our example, you have to import this class from our library to use it. You'll see that in an example here. So here I've got my 2 variables. This is what I did when I first made it. I have a pasta box, that's an uninitialized variable. And then I have a cereal box that I created, right? And it's a rectangle that has an x, a y, width, and a height. And then when I said over here, pasta box equals cereal box, what happened? I then have 2 names for the same object. I have cereal box and pasta box that now refer to the same rectangle object. So what can I do with this rectangle? Well, we're going to have what we call methods. We have 2 different types of methods. These are my actions that I can do, such as print line, which we saw before, or painting the house or changing the house color, things like that. We have accessor and mutator methods. Accessor methods are methods that don't change the state, but gives me information, like what color is your house? Where is it located? Whereas a mutator method changes the state of an object. Maybe I have a paint method, or I have a install new windows method, something that changes an attribute of the house that I made with that blueprint or that object. Some of the common methods in the rectangle class would be translate, get x, get y, get height, and get width. So translate, for math teachers, understand translate is a shift or a movement of the rectangle. So that's a mutator method. It changes my x and y coordinate. Then I have get x, get y, get height, and get width. This gives me or returns the values of x, y, width, and height. So these are accessor methods. And let's look at some examples here. So here's some lines of code. Serial box.translate 1525. What does this do? It would increase my x and y value. My x would increase by 15. My y value increases by 25. It changes the location. What does serial box.getX do? Well, serial box.x gives me the x coordinate, and I put it in a print line statement. So it's going to print the x coordinate of my serial box. All right. Here's a program called Move Tester. Notice at the top here, I do have this import Java AWT. That's a library. I imported my rectangle class so I can use it. Notice here, I now created a rectangle called box equals new rectangle, and I gave it the same numbers I did before, x, y, width, and height. I called the box.translate method, so it moves my rectangle. It just gives it new coordinates. I don't actually see a rectangle moving. And then I have this after moving, and I get x and get y. So what's going to be displayed? Well, let's go ahead and look at that in a second in JGrass. But something else I want to do is I want to also, can I do these other things? Can I display the width and the height of the rectangle as well as the area or the perimeter? Well, let's try this using JGrasp. So here's my JGrasp, and I'm going to go to my Move Tester program. And here is what we have so far. So I've got move the rectangle, and I'm going to go ahead and run this program as is with what I have. This is what we displayed earlier. So when I run this, it's going to print out 20 and 35. Why? Because my XY was originally 5 and 10. Then I added 15 to my X and 25 to my Y. So as a result, I now have printed out my X and my Y, which is 20 and 30. Let's go ahead and add some things. We want to know, can I get the width of the rectangle? So let's go ahead and type into my program here. I'm going to add another system.out.println, and I'm going to print out, say, the height. So I'm going to say box.getHeight. Notice I use camel case, and I always put parentheses at the end of my methods. When I call my method, even if there's no values in the parameters, there's my get height. And now I can also, I'm going to copy this because I'm being lazy, and I'm going to change this to get length or width. Sorry, it's width. Get width. WIDTH. Get width. Get. Put it here. This is what you get with live coding. And there's my get width. Now I'm going to run this program, and I'm going to compile and run it. So there's my compile, make sure I got no syntax errors, I run it, and it prints out my x and y, and then of course my width and my height, which we know is 20 and 30. We saw that in the example. But what about area? Can I print out the area? Well, I don't have a get area method, but I can do some math. I can say system dot out dot print line, and I'm going to take box dot get height and multiply that times box dot get width, semicolon at the end, and that should print out my area, which is, we know, the height times width of my rectangle. I'm going to build, and no errors. I run this, and it's going to print out 600, which is 30 times 60. That's going to be the area of my rectangle. So I did some mathematical calculations, as well as calling some accessor methods and some mutator methods for my rectangle. And you can also then go ahead and type in code to find the perimeter of the rectangle if you like as well too, and play around with that. This file, move tester, is also in Module 1 on eCampus. All right, let's talk about strings. Strings, we have the last type we're going to talk about here in this module. String is a sequence of characters. Strings are objects because we have a string class. So as a result, we also have string methods that we're going to look at here as well too. A string is a series of characters. It usually could be letters, but it could be symbols as well too. Anything that we're going to denote inside quotes. So the way I create a string is I could say string name equals new string, just like I did with new rectangle, and I'm going to send it the word Ted. So my name is going to have the word Ted, and that's how I construct an object. Strings are unique because we use strings so much that Java gave us a shortcut. We can actually just say, instead of saying equals new string, we can just say string name equals and then give it the word, kind of like a simple type. So string in this case behaves like a simple type, like an integer or a double, because I can just assign it a value. But I can call methods on the string as well too. So I can say int n, that's an integer, equals name.length. That's a method I'm going to call. It's one of my attributes. What do you think length is? Length is going to be the length of the string. In this case my name is Keely, 1, 2, 3, 4, 5 letters. So n is going to have the value of 5 because name.length is 5. Some other things we can do with strings. We can put them together. We can attach them to each other. And we're going to use the plus operator. So we know in math, plus is addition. But what does it mean to add strings together? Well, it means it's going to put them back to back. So you'll notice here I have a string F name is Ted, and I have a string L name is Lasso. Great television show, highly recommend it. And if I put them together, F name plus a space plus L name, and I use a concatenation operator, I can say name is now Ted Lasso, and it'll be all together. Another thing I could do is I can attach names with numbers. If I have a string A that is agent, and then I said name is A plus 7, agent plus 7, name is now going to have the value agent 7. So if I put a string and a number together, it makes everything a string. This plus operation, the concatenation, is really useful because now I can reduce my code, right? Remember before I did like the total is and then put total on a separate line, I had a print line statement. Well, now I can just say the total is and then put plus a variable, and that'll put it all in one line, which is really convenient as well. So concatenation is very handy. We'll see that a lot. So here are some methods of the string class that we're going to use. There's a constructor that I use to make the string objects, but there's the length method. Length tells me how many characters are in a string. There's also substring. I'll talk about how that works. Index of, and we'll use equals and compared to later on. But let's focus on these two right now, substring and index of, and how that works. So the substring method gives me a portion of the string. So let's say I have a string called theater. So string green equals theater. What we do is Java numbers each of the characters in here, and we're going to number them. In this case, there's 7 letters, but we number them starting with the number 0. So the first one is 0, 0 through 6. And each letter has its own index number. So if I say greeting, don't know why it's called greeting, but the word's theater. Greeting is my variable. Dot substring gives me a portion of a string, and I say 1, 5. So the two numbers represent where I start. So I'm starting at position 1, which is H, and then 5 is one number past what I want, or at the bottom there it says past the end. it's the first the first letter I don't want to include in my substring. So 1 comma 5 is going to give me 1, 2, 3, and 4. It's going to give me the word heat. So sub now equals heat. In this example, substring 0 comma 3, 0, 1, 2, not including 3, sub is going to have the value of the. And then substring 2, if I put one number in there, it's going to give me from that number all the way to the end. So if I say substring 2, it's going to give me 2 to the end, which is E-A-T-E-E-R. It's going to give me eater. And so I'm going to supply my first number and my past the end number, right? The first position is 0. The last position is going to be the length minus 1 for the total, for the last letter, because length is 7 and 6 is my last letter. But the length of my substring is going to be whatever number I put in there minus start. So 5 minus 1 is 4. Heat has 4 letters. 3 minus 0, the has 3 letters. And then 2 just gives me 2 to the end. Another method that we can use is called index of. An index of is like the opposite. It says, can you search for a word? And it tells you the position where that word starts. So for instance, if I say greeting.index of the, well, where does the start? The starts at position 0. Value is now going to have the value of 0. Index of 8 starts at position 3, so it's going to return a 3. Index of E, well, there's 2 E's at 2 and 5, but it's only going to give me the first one. So index of E is going to be 2. And then what if I can't find a string? What if I look for the word ah, A-H? Well, there's an A and there's an H, but there's no ah. So because I can't find it, it's going to return -1. As it says up here, it returns -1 if the string is not found in the string itself. So let's do a quick check here. If I have S is the word agent, what is going to be S plus length? Let's think about that. So it's going to be agent, and then S dot length is a number. What number is it? And I put it together. S is now going to have the value agent 5, right? So I got rid of the old value of S, and I made it S plus the length, and S is now agent 5. What about Mississippi? I got the word, let's say I've got the variable river, and it holds the value Mississippi. What is the value of river substring 1 comma 2? Well, let's see. So M is in 0, I is 1, and then I don't want 2, so I just want one letter. So 1 comma 2 gives me one letter, gives me the letter I. What about substring 2 comma river.length minus 3? Oh, gave it away a little bit, but let's look at that. What's river.length minus 3? So length is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 minus 3 is 8. So I'm going to go from 2 up to but not including 8. So I'm going to go 0, 1, 2, which is my S, 3, 4, 5, 6, 7, which is the second I, but then don't include P to the end. So it's going to be C, C, SSI, SSI is what we're going to get there when we do that substring. All right, a couple other things we can do with strings. How do I get the first character? So I know I can start at 0, use substring, but I only want 1, so I went from 0 to 1. So let's say I had a string called word. How would I get the first character? Word.substring 0, 1. It's going to be just the first letter. This is going to come in handy in one of the assignments that we're going to do. How do you get the last character? Well, the last character is at the name of the string, so word.length minus 1, and then to the end, well, there's nothing else after that last character. It's just going to give me that one character. So word.length minus 1. What about everything except the first character? So I'm going to start at the second character and go all the way to the end. Well, the second character is at space 1. So word.substring 1 gives me 1 to the end. And then how do I get everything except the last character? Well, it's going to be word.substring 0, comma, word.length minus 1. Give me everything up to, but not including the character that's at word.length minus 1. So it's going to give me everything except the last character. So there's some good ways we can manipulate strings, right? I can get one character at a time. I can get the last character, the first character, everything but the first, everything but the last. Okay, so we'll talk more about strings in our assignment. So here we go. Last thing I wanted to cover here is something called static methods. These are methods that I know we said we always create an object with our blueprint, and then we call the methods on those objects. Well, there's a couple classes that are special classes. We call them utility classes, where we don't have to make an object first. There's a math class out there. There's a lot of math functions. And in the math functions, I'm going to use the math class, but I don't have to make a math object first to use them. There's a math function called, I know it looks like it says squirt, but that actually stands for square root. And then there's also pow, which stands for power. And here are some classic, some very common mathematical functions that we use. We use math.square-root, math.pow, math.exp for e to the x, math.random, and then there's also sine, cosine, and tangent. Math.round allows us to round a number. Lots of different math functions in here, and you'll see the math class being used in some examples. So here's an example of here. So I can actually take this expression in Java, negative b plus math.square-root b times b minus 4 times a times c divided by 2a. That's actually our quadratic formula, just the positive version of it, if you translate that down to English. But let's talk about math.random for a second. Math.random actually gives you a number between 0 and 1. It gives you a random math number. When I say random, it's approximately a random. It's not truly random. This actually pseudo-generates a random number. It looks random. We don't need to get into the details of it, but it just basically gives us some number greater than or equal to 0 but less than 1. And what can we do with that? Well, what if I want to generate a random number between 0 and 100? Well, all I really have to do is just say math.random and then multiply it by 100, right? So whatever random number it gives me between 0 and 1, if I multiply it by 100, I'm now getting a number between 0 and 99.99, right? That's one way. What if I want to generate a number between 40 and 50 though? Well, let's think about that. My range is 10, but then it's not 0 to 10, it's 40 to 50. So what I'm going to do here is multiply it by 10 to get a random value between 0 and 9.999, but then add 40 to it. So now it's between 40 and 49.99999. And so this is how math.random is used. You'll see some examples of that as we go through the course, but that's something, again, it's using the math class. I don't create an object, I just say math.random, and then I use it from there. Okay, and one last topic about this with numbers and strings. It's not tested, but you'll see this used in a couple sample programs that I'll talk about. We use integer.parseInt to convert a string to an integer, or double.parseDouble to convert to a number. And then there's also, we know we can concatenate things to convert a string to a number, or we can use integer.toString. This isn't tested, you don't need to type this. However, you will see it in a couple examples that I use. All right, let's look at some sample questions before we get to the assignments about that you might see on the FTCE exam. So here's one. It says, read the question and select the best response. What would be the output when the following section of Java code runs? Now, I have three variables here, X, Y, and Z. And one important thing to note here is when I assign one variable to another variable, that variable gets copied. So let's, and it might even help to write down what each variable holds as we are moving along here. So let's look at this. So I started out with X equals 5, so that's an integer, and I've got Y equals 10, that's another integer, and then I have Z. Z equals X. So what's Z going to hold? Z is now going to have the value of 5. So I'm going to make a note of that somewhere, that Z is now going to be 5. And then it says X equals Y. Well, now X is going to have the value of 10, right? Because that's what Y is. So, so Z is 5 and X is 10. And then we say that Y is equal to Z. Well, now Y is going to be 5 because that's what Z is. So now X is 10 and Y is 5. Basically, we swapped the variables, right? And if I print line X and Y, what's going to get printed out? X is now 10 and Y is 5. So it's going to print out C 10, 5. All right, let's try another one. How about this? Read the question, select the best response. When using, what would you use string methods for? What would be a strategy for using a solution for using string methods? Remember, string methods were things like substring and index of, where I can get the length, I can get a small portion of the string. This says when I want to reverse the letters in a word, when I want to create a multi-dimensional array. We haven't talked about arrays yet, it's not that one. When I want to print a line of text to the screen, we would use a method, but it's not a string method. Printing to the string would be a system.out method. And then what about constructing an instance of a class? Well, we wouldn't use a method for that. We would just say equals new string or equals new rectangle or equals new house, right? So the answer would be A from when reversing letters in the word, because I know I can use the string methods to get individual letters of a string using the substring method, and I could put them in reverse order and things like that. All right, how about this last one? This one says, according to the following segment of Java code, which Java string method would be used to print extra to the screen? So I've got text that says extra special. I want to know what would finish that code where it says string part equals, and then it says some sort of string method I'm going to call here, and then I print out part. So what would I do here for part so that I could get just the word extra? It's going to be text.substring what? It would be text.substring 05, right? The answer is B, because I want to start at 0 and get 0, 1, 2, 3, 4. I don't want 5, which is the space character there. So I'm just going to print extra by doing substring 0, 5. The answer is B. All right. I want to talk about one last little thing that's not on the test, but I want to just go over this because you're going to see this in the program. How do we know how to print stuff out, but how do we read things in? This is not directly tested. You'll see something where they'll say a word gets input, or my values were input in, and you don't have to worry about the code for that. There's something called the scanner. We know how to print line using system.out. There's something called the scanner that was added to Java that you can allow to input from the keyboard. That makes it pretty easy. You can input in doubles or strings. But there's another way you can do it using something called JOption pane and a show input dialog box. And this is a graphical user interface. And this is what we're going to do some examples with. I'm going to show you this, an input dialog window. How many nickels do you have? This is like a little pop-up window, and the code for that looks like this. You just do a JOption pane, show input dialog, how many nickels do you have, and it gives you a pop-up window. And then you could, remember we talked about converting? This is where converting comes in handy. And then conversion throws an exception if you try to convert a number that's not really a number. We'll talk about those later. You could also do a show message dialog as well, and a show message dialog will display a message for you. So there is a program on there called Chatbot on eCampus, and you should download that and read through it, and you can understand how it works. And it uses substring and different and addition and some mathematical operations to kind of act with the user here. I'm going to go ahead and run this on my computer. So let's go ahead to the Chatbot program, and I'm going to go ahead and run this, and I'll see if I can display these on the screen. So first it says, hi, would you like to chat today? And I'm having to drag it over from my other screen, but it says, what is your name? So I'm going to put in my name, and I'm going to say Tim Gallagher, and I say okay, and then it says, hello, Tim Gallagher, nice to meet you. It remembered my name. That's just a variable, right? And then it says, I like names that begin with the letter T. Well, how did it know my name began with T? Oh, look at the code. The code's right here. If I look at the code, it says, I like names that begin with the letter, and it did name.substring. How did it get the first letter? 01. Name.substring 01. And then it says, did you know your name has 13 letters? Well, look, it printed out. Did you know your name has name.length letters? So here we are, creating our very own AI program. What is your favorite snack? I'm going to say Reese's for my favorite snack. And it says, I don't like Reese's. My favorite snack is microchips. Ha 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 ha. All right, and then it says, how old are you? I'm going to put in 29. I hit OK, and it says, did you know that in 10 years you will be 39? Wow, that's old. How did it do that? Well, we can see the code down here. We asked it for a number, it converted it to an integer, and then it took and just wrote out the age plus 10. So again, all those features that we used in here, and then of course it stops with goodbye. All of those are in that code. Read that code, run through it, understand how that code works, and play around so you can get an idea of some of the options of some of the code that we've learned in this module that you can now convert and use this in programs. All right. So let's finish up. What are we going to be doing here to finish up over the next couple weeks? So Unit 2 is all about using objects. So go through, this is all part of Module 1. You're going to look at Unit 2 in CS Awesome, and there's an assignment up there called Pig Latin. And if you remember Pig Latin is where you take a word and you take the first letter of the word and you append it to the end of a word and you put AY. So if I had the word desk, it'd be esk day. Right, so I take the word without the first letter and I put it at the end. How can I do that? Well, I can use concatenation and I can use substring to get portions of my word. Check that out in section 2.7.4, and that is going to be one of the assignments that we're going to turn in. Take a screenshot of the solution with that, and you'll see the green pass boxes that we have on the screen when you do that as well. By the way, these first few sections in CS Awesome uses something called a turtle. It's a turtle class. You make a turtle object and you make a turtle move around on the screen. It's all about how to use objects and methods. You don't have to go through any of that if you don't want to, but if you want some practice using objects and calling methods on objects that you make from a class, the turtle class is a good example to do that with. And finally, the back half of Unit 2, of course, ends with our multiple choice exercises. We know that our multiple choice exercises are great practice problems, so you want to do that as well too. And the last project that we're going to do is something called our DJ wrapper name. And there's some code in eCampus that we're going to load into JGrasp and open up this program. And the code asks you for a name, and it's already written up there. And we want to generate our possible DJ or wrapper names, and you can see the comment in the code. So let's go ahead to my code, and I want to pull up the DJ wrapper name example, and let's look at this. So it says that public static void main string args, we get the full name, please enter your full name, and then you've got to generate their wrap name. So for instance, here's what we should do. If I entered in Tim Gallagher, we have these 4 different names. We're going to take the letters MC plus the first initial of the first name followed by dog. That's my first name. The word tenacious followed by the first initial of the first name and the first initial of the last name. The word Lil followed by the first initial of the first name, a hyphen, and the first 3 letters of the last name. And then your first name followed by $1.50. So for instance, if I ran this program and I put in Tim Gallagher, it should print out MCT Dog, Tenacious TG, Lil T Gal, and Tim $1.50. That should be the names that I print out if I run this program. I'm going to show you a finished version of the program to show you what this prints out. So here's my key, and I'm going to run this. And when I run this, it'll say, I get this pop-up window here, enter your full name. So I'm going to put in Tim Gallagher and hit OK. And then what do I get? I get MCT Dog, Tenacious TG, Lil T Gal, and Tim $1.50. So we know how to get the first letter. How would I get the first letter of the last name? Could you use index of to search for the space and then start one number after that? Think about that. I have some hints I'll give you on how to do this as well too. So I want you to think about that. All right, so let's finish up by looking at what we're going to do to wrap up this session. So here's what we should do over the next few weeks. I recommend working through CS Awesome Unit 1 and 2. That'll give you a good basis for Java. Try the multiple choice questions at the end of CS Awesome, because we know our exam is going to be all multiple choice questions. So even if you're not quite sure or comfortable with writing code, be comfortable with answering questions about it. Practice your skills there. I would look at study.com as soon as you have the access code for study.com, which we should be able to get to you soon. And then download the sample files that I have up there in Module 1 and pull them up in JGrasp and see how they work. Here's what we need to do. First of all, sign up for CS Awesome and install the JGrasp IDE, again, whether it's on your personal computer or have your IT people do it at school for you. Download the cache register.java program and complete that in JGrasp, right, and submit that to eCampus. That's going to be the one where we do the total and the item count. We want to do the Pig Latin program, which is just simply taking one word and giving the Pig Latin version of that. You'll see that in 2.7.4 of CS Awesome. And then we're also going to do the DJ rapper name project as well, where I'm going to generate those rapper names. That hopefully should overall take you just a few hours, 3 to 4 hours in or maybe just 3 hours, less than an hour for each program, I would imagine, in those 3 files, and submit those to eCampus. And then don't forget to take the Module 1 quiz at the end. We want you to score an 80% or better, so you can take it as many times as you want. It's all multiple choice, and it's all based on things that we've covered in this module. So that's it. Again, make sure that you complete those 3. If you want to spend some more time going through study.com or going through CS Awesome to make sure you get a good solid grasp on Java and how programming works, that's fantastic as well. I did put a file called Module 1 Hints in there, so there's some hints to get you started on each of the 3 programs. But if you have any questions or comments whatsoever, please don't hesitate to reach out, send me an email, let me know what your problems you're having. And then don't forget, starting next session on March 3rd, I will be here a half an hour before and a half an hour later, so I can answer some individual questions that you might have about your projects or about the module that we just completed as well. All right, that's it for us here. I will see you at the next session. Good luck, and let me know if you have any questions.